All right, fourth period. Getting right into it. You're going to watch this video, and then you got a simple homework assignment all about factoring. Just like we talked about in class, I started teaching you guys, and then you were zoning out on me. So hopefully, right as class starts, it'll sink in a little bit better. Okay, so this is all about factoring. The next unit, we only have 2 units left. Chapter 9 is the one we're moving into, and then we have a final unit that is just kind of a little bit of collection of what I think are the most important things left for us to learn. I kind of just combine a few things together. But in order for you to be good at Chapter 9, you have to be able to do this. Factor. So I am going to show you 3 of the primary factoring methods today, and then I'm going to introduce the worksheet. Make sure you see that part because the directions can be confusing, but they're actually fun if you know what's going on. So there are 3 big factoring methods that you got to know. The first is called the Gcf method, the greatest common factor method. And what that method tells us is if your terms, so like when I'm looking at 18, like this is a term, this is a term, this is a term. When I'm looking at 21, this is a term, this is a term. When I'm looking at 20, this is a term, this is a term. The Gcf method tells us that you can pull out, you can factor out any common factors. And you want to, so the Gcf method tells us to pull out common factors. Here's what I mean. Number 19 is about as simple as it gets. There are 2 terms there, 5x minus 25. The first question you have to ask yourself every single time on one of these problems is there a GCF? And there is. There is something that can go into both 5x and 25, and that is 5. So once you've identified a GCF, you pull it out. What that means is I write it outside of the parentheses. And then now I have to fill in, I'm going to put something here, and then I'm going to have my subtraction symbol, and I'm going to put something there. So it's almost like you're doing reverse distributive property. If I pull out a 5, what's left in this term? What's 5x divided by 5? Well, that would just be x. And if I pull a 5 out of that term, what's 25 divided by 5? Well, that's just 5. So my answer is 5 times x minus 5. This is in standard form. Okay, this is in factored form. See how it's broken into 5 multiplied by x minus 5? So those are the 2 factors. If you want to test to see if it's right, you can just do distributive property. 5 times x is 5x. 5 times negative 5 is negative 25. Yep, that matches, so you know you did it correctly. But this right here in the box is the answer. I pulled out a GCF. Look at 20. 49x minus 7x. Do they have a GCF? They do. They both share a 7, but they also both share an x. 49x, there's 1x in there. 7x squared, there's 2 x's in there, so they at least share 1x. So the x, what just happened? Oh, there we go. They share a 7 and they also share an x. So the GCF is 7x. So that is what I pull out on the outside. And then I have to think, what's going to go in the parentheses now? What would I need to multiply 7x by to get to 49x? Well, that would be a 7. Let's test it. What's 7x times 7? That's 49x. Yep, that's correct. And then I put my subtraction sign. And then what would I need to multiply 7x by to get to 7x squared? Well, that would need another x. Let's test this. I think that's the answer. I'm going to go ahead and box it because I'm pretty confident. But let's go ahead and check it. 7x times 7, 49x. 7x times x would be 7x squared. Is that correct? Yeah, it is. So that checks out. So that is the first method, Gcf method. Greatest common factor. You're always looking to see if you can do that. You always try this first. Okay, the second method is what I think is the most simple one. I call it DOS, difference of two squares. What do I mean by squares? I mean perfect squares like 1, 4, 9, 16, etc. Or what else are perfect squares? X squared, y squared. What about x to the 4th or y to the 8th? Like those are perfect squares as well. And you only ever, the secret for this is you always look to try this if there are only two terms with a subtraction symbol. If there are two terms with a subtraction symbol, like this one right there, that should send a siren off in your head of like, hey, that might be the difference between two perfect squares. So let's check. X squared, that is a perfect square. There's our minus sign. And 16 is also a perfect square, 4 times 4. So we know that we can solve this using difference of squares method. And here's the method that you might want to write down. If you have a perfect square minus another perfect square, it gets broken into two sets of parentheses where the square root of the first term goes in the first two slots. So the square root of a squared, that would be a times a. And then the same thing for the second. This would be b times b. And with difference of squares, you always do 1 plus and 1 minus. That's the pattern for the difference of squares method. We'll just title that DOS method. So I'm going to follow that exact formula right here. X squared minus 16, that's going to be broken into two parentheses. X squared gets split into x and x. 16 gets split into 4 and 4. And we always have 1 plus, 1 minus with difference of squares. That is the answer. It is in factored form now. One of the factors is x plus 4, and the other factor is x minus 4. There's two factors there. You don't believe me? I won't do this for all of them, but I'll check. X times x is x squared. X times negative 4 is negative 4x. 4 times x is 4x. 4 times negative 4 is 16. Negative 4x and 4x cancel out, and I'm just left with x squared minus 16. Yeah, it checks out. I did it correctly. I challenge you to try this one on your own because it's very similar. Pause the video, try it, and see if you get it right. Hopefully you pause the video because here's the answer. Okay, that's difference of squares method. So then the last method is what's called, what I often call the guess and check method. It's what you look for if there are three terms. If you see three terms, you're probably going to use the guess and check method. Okay? What do I mean by that? Let's just shoot to number 13. We did this already, so I'm hoping this feels a little bit like review, but if not, don't worry. 1, 2, 3, 3 terms. So remember, this is the one where I automatically set it up with my parentheses, and it's what factors of 24 can help me get to a negative 10. So my factors of 24 are 1 and 24, 2 and 12, 3 and 8, or 6 and 4. And honestly, this is a tricky one because 6 and 4 can give me 10. So can 2 and 12. 12 minus 2. So I'm gonna have to be careful here and look and see. This needs to be a positive 24. So if you see a positive sign here, then you know that both of your signs are going to be the same. So we know that this is going to be a double negative here. So that matters. So let's start splitting it up. X squared just goes to x and x. And then I'm either going to use 6 and 4 or 2 and 12. I'm going to use 6 and 4. Because if I used 2 and 12 and they were both negative, it wouldn't work out. So this is my only option here. If you want to check, this is why it's called guess and check. I recommend that you do the outside numbers. X times negative 4 is negative 4x. And the inside numbers, you make a little smile to check it. It looks like a face. Negative 6 times x is negative 6x. When you add those together, it's negative 10x, which is what I was looking for in the middle. So that is my answer there. I completely factored this. So remember, this is a factor. This is a factor. There are two factors. Number 14, this was a factor, this was a factor, there were two factors. Okay, for my last one, let's look at 16. Because 16 is a little different because of this 2. It still has 3 terms, so I know that it's going to be guess and check. Can I take out a GCF? This is 2, this is 11, this is 15. Is there any number that can go into 2, 11, and 15? If so, we could pull that out. No, there's not. So we're just going to go into this. 2 sets. Factors of 15. But hey, the fact that there's a 2x squared there means we can't just put x and x. Because x times x is just x squared. We're missing the 2. So one of these is going to have a 2 stuck on it. So I'll just stick the 2 on the first one. 2x times x is 2x squared. That takes care of that. And now I still pick factors of 15. 1 and 15, 3 and 5. Those are my options. I'm trying to get an 11. So if I plug a 15 here and a 1 here, that would be 30 and 1. That's way too big, so it can't be that. What if I put the 15 here and the 1 here? That's 15, and that's 2. That's going to give me 17 or 13. That doesn't work. So it must not be 15 and 1. It must be 3 and 5. Let's put the 3 here and the 5 here. Let's test that. 2x times 3 is 6x. 5 times x is 5x. Hey, that can give me 11 if they're both negative. Nicely done. Guess and check method, and I solved it. So those are the 3 factoring methods. Listen, y'all, if one of the main takeaways from this class is being able to factor. So you can literally go to YouTube and type in either of these factoring methods. You can say GCF factoring, and a slew of videos will pop up. You can say difference of squares factoring, and a slew of videos will come up. Or you can say, you can type in factoring trinomials. That's just things with 3 terms. And the guess and check method will pop up. All right, but you're going to get a chance to practice this today with people around you. And some are on different journeys and are better at this than others, so work together. Let me show you what the worksheet looks like and explain it a little bit, because I don't know if we've ever done one of these before. It's from my main woman, Verge Cornelius. I've been using some of her resources for a long time. She rocks. Never met Verge, but I like her stuff, and I give her credit whenever I can. So here's where you start. This is number 1. And notice, it has a problem right here. It tells us to factor that. But then it gives us an answer. This answer does not go with this problem. Look what the directions say. Begin in the top left cell marked number 1. That's what we'll do. Factor the polynomial, and then to advance in the circuit, you hunt for just one of the factors as your answer in a different cell. Let me show you what I mean. It says to factor this. I'm thinking of my methods. This looks like they share something in common. This has 2 x's in it. This has 3 x's in it. So to factor this, this has a GCF of x squared. So I'm going to pull that out on the outside, and it's going to leave behind a 1 minus x squared times 1 is x squared times 4x goes there. So there is my answer right there. So I need to look at all the other squares, and I need to look for either an x squared somewhere in there or a 1 minus 4x. So let me look around. It's not that one, it's not that one, it's not that one. I wouldn't make these marks if I were you, but I'm looking for x or 1 minus 4x. No, no. Hey, there it is. Bing, 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 bing. So what that means is this is number 2. Okay? And this would be where I start number 2. You look at this, you're like, Smith, what the heck, x and y's? This is a GCF problem. Ask yourself, what does this have in common with this? They can share numbers, they can share variables. 18 and 9, they both share a 9. X squared and x, they both at least share 1x. Y and y, they both at least share 1y. So see if when you get here, the GCF is 9xy. See if you can then finish the rest of that problem. So what you do is you solve number 1, then you use your answers to try to advance to the next squares. When in doubt, just factor all the problems if you get confused, and we'll go over these on Monday. Finish this and submit it. Peace.